Greetings and hello everyone. My name is Heidi Bussey, and on behalf of Fukado and myself, I welcome you to the Research Methods course for the Owassa University's MSc Students in Applied Human Nutrition. How is beautiful Owassa? I hope you are doing well, and I'm only sorry that I'm not there to join you in person for these first weeks of the course. However, you have the wonderful leadership of Ada Fukado, who is facilitating the sessions with you until I am able to join you later this semester. So welcome and thank you, and I look forward to meeting you all and getting to work with you as we go through this process of thinking more and helping you develop nutrition research projects for your major. So as Fukado already covered some of the things with you on Tuesday's first session, we'll skip some of the slides in this presentation. So this session should last about 40 minutes total. What we'll do today is that we will start by going over the course goals and objectives, since you guys have already done group introductions and sharing amongst each other. After reviewing the course goals and objectives, we'll talk about the agenda and the assignments to make sure that it's clear to you what the expectations are. After that, I'll do a short lecture on research and study designs, and then we'll wrap up by going over expectations for assignment number 2, the study designs assignment. So to begin, since we've already done the introductions, let's talk a little bit about the course goal and objectives. So the overall goal for this Research Methods course is really to help prepare you to develop and conduct applied human nutrition research studies. Because this course is focused on applied human nutrition and not dietetics or nutritional science, we'll emphasize approaches that combine qualitative and quantitative methods. So after completing this course, you should be able to have more confidence in describing the theoretical frameworks used in research and compare the relative advantages and disadvantages of different study designs. 2, be able to design a research question and identify the steps in creating a study. 3, be able to select and design the appropriate methods and tools to administer, manage, and analyze study data. 4, conduct data analyses using some basic software packages. 5, understand human subjects and research ethics considerations. And then 6, consider how to report what you have found from your research. So we're going to emphasize both research and scientific writing, as well as giving oral and formal presentations. So we want to start by going through the syllabus to outline our course expectations and answer any questions you may have. Hopefully you all have had a chance already to download and look at the course syllabus online. And I want to highlight a few things. So the website. If anyone was not able to access the shared website, please let Fukado or myself know. It's important that you're able to access it so that you're able to get regular updates, and also we will keep the website open after the course ends. So hopefully the resources can be there and available to you in the future should you need them. Second, was everyone able to download the course syllabus? If you have not seen a copy of the course syllabus, know that I'm sending paper copies with my colleague Sonia, and Fukado should hand them to you next week. But please let me know in the meantime if you have not seen the syllabus. Course content. So our course will meet every Tuesday and Thursday from now through the middle of January. The course will be held at 1600 European time in Owassa, and it's mandatory that you attend every session. If you have a conflict or get sick, please email both Fukado and myself ahead of time so that you can let us know and get permission to be excused. But know that we'll take attendance at every session, and it's part of your grade to be here. But more importantly, we'll cover content every session, and so it's really important for you to be part of the class and the group process to keep up with the pace of this course. The next thing I want to talk about is the course syllabus. So the course syllabus has 4 primary units or modules. We'll start the first 2 weeks with an overview to research, how to create an effective research question, how to select an appropriate study design, and also the steps in the research design process. Our second unit will focus on quantitative methods, with topics to include sampling and sample size, survey design and data collection, and statistical analysis. Our third module will be in qualitative methods. This will be a shorter unit, but will introduce you to qualitative methodologies, methods, and analyses, as well as processes for managing and interpreting your data. Excuse me, I have a cold. Glad that you're farther from me so I'm not passing on my germs. And then our final and fourth unit will be on your culminating project, where both in your small groups and your independent projects are wrapped up and presented. The next area I want to go over is guest speakers. So throughout the course, we are very fortunate to have several colleagues who have agreed to give guest lectures. This is a great opportunity for you to hear perspectives from people who conduct research, including nutritional scientists, epidemiologists, statisticians, and also hopefully we'll get a policymaker. So we have listed the speakers in the course syllabus, but as we add speakers, we'll update this. Take advantage of our guest speakers not only for the lectures that they share, but as an opportunity to expand your professional network and also learn from them their experiences about collaboration and working on research teams. The next thing I want to go over, are the assignments. So for the assignments, page 6 of the syllabus outlines each one. It may seem like a lot of assignments, but most of these are short, and they're broken into small steps to make your process easier. So having multiple assignments also gives me and Fakadu, as your instructors, opportunities to give you feedback along the way. So the group project is a way for you to practice in small groups coming up with a research question. One of the most important lessons and also challenges of research is how to work together in a research team. So part of the reason that we want you to work in small groups is really to gain this experience of communicating and collaborating effectively. You will create your question early in the semester, and the rest of the semester will go through the process of the study design steps with your classmates. And some of the key outputs for your group project will be designing a simple questionnaire, testing the validity of the question, so doing a brief pilot of it, analyzing the results that you get, and then summing up what you learned from that process and recommendations for an improved questionnaire. Your second main assignment will be your independent project, and this is due at the end of the semester. So you will need to create your own research question and study design over the course of the semester and write up a 7 to 10 page research proposal describing it. You will not need to conduct the actual research this semester. Again, this is just a research proposal. But ideally, your plan will inform or perhaps be part of your master's thesis. To build your skills in leading and facilitating discussion and help you as a class prepare for the final exam, the final assignment that we'll have for you is that you'll sign up to work in groups of 3 to 4 students the week before your final exam to facilitate a discussion on one of the course thematic areas. So you'll be expected to facilitate about 30 minutes of class time where you can either give a presentation or have the class participate in a discussion or other activity. We'll provide more information for you about that more in the middle of the semester, and let us know if you have questions in the meantime. Finally, as you know, you'll have a final exam. And as mentioned before, we expect you to attend all of the classes unless you request prior approval to be excused. The grading scale is in the syllabus. So with that, and it follows the Awassa University's grading parameters. So please let me know if you have any questions about these course expectations. So with that, we'll start our lecture. So as I mentioned, this is an overview lecture to research and study designs. And for this part of the session, let's start by thinking about this. What is research? In the baseline questionnaires that many of you submitted, for those of you who had questions, this came up commonly, is to explore the question of what does it mean to do research and what is it? So the definition of research is a systematic inquiry that investigates hypotheses, suggests new interpretations informed by data, and poses new questions for future research and those in your field of practice to explore. So there are three things that I want to highlight in this definition of research. And I'm sorry the animation is not showing on your screen, but let me highlight them point by point. So first, research involves asking a new question that nobody has asked before and forming a hypothesis that you can test to see if it answers your question. So research is not about repeating or copying somebody else's study, but it may be summarizing literature about a topic in a way no one else has previously done. So to do this, research involves understanding what is already known and not known about a topic. It requires good judgment about research questions that would be meaningful and relevant. And once you have your question and hypothesis, research then involves step 2, which is doing the necessary work to find the answer. And this typically involves designing the study, collecting data, and then analyzing that data. And then the third phase of research is communicating the knowledge that you have acquired to a larger audience. If you only ask the questions, but you keep them within your own lab or keep them only to yourself, they're not doing good to affect the larger body of practice. So research is also unique in that the new knowledge that you're able to create can be used by others, whether that be people in your field of practice or policymakers or community members themselves. So if that's what research is, why is it important to conduct research? So if you want to pause right now for a few seconds, I'll let you just shout out answers and discuss yourself. Why is it important to do research? I hope that's giving you time to shout out a few suggestions and share some of your thoughts and ideas. So as you probably knew, if you were able to share, there are many reasons to conduct research. If you may remain in an academic career and pathway, which I know some of you are interested to do, research will be important for you to conduct in order to advance in your faculty position, in order for you to gain promotions, and in order for you to be respected in your field. But even if you do not continue in academia, even if you work for the government, or if you work for an NGO, or in some other field, as nutritional science majors, research is very important to your practice. You may want to conduct research in order to inform the design of programs or activities. Or you may want to get a job with industry and use research to inform product development or understand marketing trends so you can come up with nutrition products that you can sell to the market. Or you may also want to collect data as a tool to advocate for policies, strategies, or funding that would benefit populations or communities that you work with. So an example of that is you may want to conduct a rapid cross-sectional study to identify the prevalence of anemia or stunting within your community. And while you could use this data to publish or present just to your scientific community, you could also take this data to the government or a donor in order to advocate for funding to address a specific micronutrient deficiency within specific populations. So with this, I want to emphasize again, research is not just for the academic community. Research is also really important to inform program planning and design, and hopefully to inform and advocate for policy as well. So finally, whether your future takes you to practice in a clinical or academic or community setting, having a grasp of research and the systematic methods that are involved will help you better critique the scientific literature and reflect on the work that you do to hopefully lead to continual improvements, again, wherever you work. So with that understanding of what is research and why do we do research, I want to share a couple quotes with you. The first is, if you don't know where you're headed, you won't know when you get there. And this is by an American athlete, Yogi Berra. So in designing research, it's important to consider the ultimate goal of your research study and plan early, because this informs the amount of time and funding that you need to budget for it, as well as the ethical implications and dissemination of your results. So it's important, again, think of the end goal so you can plan how it is that you'll get there. But I think it's also important to think of research by this quote from the Chinese philosopher Lao Tzu. So what he said is that the journey of 1,000 miles begins with a single step. And I think Lao Tzu's quote speaks to the humility of research. As scientists, there is so much we do not know and cannot control. And sometimes research plans continually change as you go step by step through the process. As you answer one question, you find that you need to revise your original question and design entirely. Or after you start your research project, your funding gets cut and you need to adapt your study methods under different funding constraints. Why am I raising this? I want to introduce you to these two perspectives to research design to convince you that there are reasons why it's important to have a big picture perspective, to see the whole picture first, but also reasons why it's important to pay attention to each step, be flexible, and be humble as researchers. And good researchers and scientists typically are able to see both. So this big picture that Yogi Berra talks about is your research design. And we'll spend most of today's lecture learning about different types of study designs. Today, I'll also introduce to you the steps within study designs. And these are the small steps that Lao Tzu refers to. As you go step by step, these are the things that may need to change. So we won't go over each of the steps in the research design process today. I'm just going to touch on them briefly. But I do want to highlight that these steps in research design are what we'll cover over the course of this semester so that you gain experience in each one of them. And that each one of these steps in the study design are what you will need to include in your final independent project and your research proposal. So, what is research design? Well, the definition of research design is that it refers to the plan or roadmap, like Yogi Berra talked about, that outlines your research strategy and process. Excuse me. So even though there are many types of study designs, research tends to follow a shared set of steps, And these steps start with defining your research question, then developing your hypothesis. Third is to select a theoretical framework. Fourth is to create your study design, to test your hypothesis. Fifth is to interpret and present your results, to improve your understanding of the problem. And what I like about this circular concept of research is that it shows research is never entirely done or finished. Really, the best research studies tend to lead to further questions. Excuse me again. And what I want to, why there's a yellow circle on study design is I want to emphasize that's the stage that we're going to emphasize in this talk today. We're going to talk about different types of study designs. But then we're going to go backward on our next seminar that we have, and we're going to talk about the process of how we come up with creating the research problem and developing hypotheses from it. Thank you. All right. So the picture on this slide describes the different types of study design models. from biological and clinical studies on the far left to then health promotion and population studies on the far right. I want to emphasize that no one study design is better than another because each question requires judgment about which design is the most efficient way to give an accurate answer. So oftentimes, and I'm sorry it's not showing the animation, but on the far left, markers of exposure. So this is referring to the randomized clinical trial, which is often held up as the best design for establishing causality and the effects of an exposure. So for example, you may randomize a population into one group that consumes iodized salt and another group that does not consume iodized salt and evaluate relationships with estrogen levels or some other outcome. However, and that is one type of study design that's usually held up as the gold or the best standard. However, there are many situations for which observational study is the more ethical choice or the more feasible option. So for example, in the case of the iodized salt incidents, you may want to first conduct 7-day recall questionnaires or use some other tool to understand a community's dietary patterns. To know if there are existing iodine-rich sources of food in the diet, and this would be important because you would want to avoid overconsumption of iodine. The relatively low cost of such a cross-sectional cohort study makes it attractive for some questions. And then if you look on the far right, policy studies to evaluate the impact or cost-benefits initiatives can be critical for answering questions that might impact large populations and society in general, and they may be more appropriate. So for example, conducting a health or economic impact assessment about iodine fortification first before making it a national dietary regulation. So as you can see, many different types of study designs that might be about a similar topic, but they're all referencing a different type of question, but they're also influenced by different factors that go into selecting which is the study design that's the best fit for what you want to look at. So, as I mentioned before, selecting your study design is just one step of the overall research process. This slide shows you the components of the research study, which we can read from top to down. So the first step in your research design process is to establish your research question. But to create a good research question, it's important to first collect information about your topic, which can usually be achieved through a review of existing literature and talking with experts in your field. Step number 2 is to articulate the significance of your question. Why is it important to ask this question? To whom? And what kinds of answers will the study provide? When you describe the significance of a question, it's important to cite relevant prior research and the problems or gaps that exist. The significance section should then show how the findings of the study will help solve these uncertainties or lead to new scientific understanding. Or it may also show how your findings can influence practice guidelines or policy. Often the literature review and synthesis done for the significance section will lead you to alter what you started with as your initial question. So note that they don't need to be static. You don't need to, and in fact, it's good to be flexible through this process. So we're going to go in greater depth in the research questions and significance process next week, but I just wanted to highlight where they fall in the research design plan. Where we're going to emphasize this lecture is on the study design. And the study design is important because it enables you to collect the data needed to answer your study question. And the remaining components of your research design, the subjects, variables, data integrity, and analyses, these are all steps for collecting, analyzing, and presenting data. So this slide basically, again, outlines the course content and what you need to submit in your research proposal. And again, for today's session, we're going to emphasize the study design piece. So, any questions? If so, please pause them. Please pause this recording and take down your questions with Dr. Zakatu. If no questions, we'll proceed to the next step, which is the 3 basic types of research questions. So creating and coming up with a research question may seem overwhelming, but it's really critical. And while there may seem to be endless types of research questions, keep in mind this tip. There are actually, most research questions fall within one of 3 question categories. Take, for example, the question, should women drink milk? And I want to ask you, do you think that would be a good research question? Should women drink milk? Well, let me respond. I would say no, it is not a good research question, but it's interesting, and it's a good place to start. So let's think a little bit more through that broad question. What you might want to start with is the first category of question, which is what is happening. So what is happening gets at a descriptive analysis of the situation at hand. So for example, rather than asking, should women drink milk, you might want to ask the question, what is the average number of servings of milk per week currently consumed in the diet of Ethiopian women? Or the diet of Ethiopian women from a specific zone like Walaita with a history of diabetes, or among children classified as stunted. So again, once you know what is happening, either from the population you are working with or from reading the barometer literature, you can clarify that question. So what is happening? It's a descriptive question, and it's simply being specific about the population and asking what is happening at a specific point in time. So again, after understanding and getting a description, you might then move on to proceed to an analytic study to evaluate associations so that you can start to generate inferences about relationships. So for this, you might want to ask, is there an association between X and Y? So in the case of women drinking milk, the question might be, do women who drink milk have a lower rate of diabetes than women who do not drink milk? When you create a question for an analytic study, you want to try to make the question as broad as possible to consider answers from multiple populations to ascertain if the associations seen in one population are consistent and generalizable with others. Or you may want to test out a hypothesis within a specific population and add more descriptors and specificity. Both are okay. Just know that they tend to require slightly different study design expectations, but they still fall within the same analytic framework of is there an association? The final type of study question might be to inform a clinical trial or a randomized trial and to establish the effects of an intervention. So it typically asks, what's the impact? So in the case of this milk question, the question might be, does consumption of milk more than 5 times per week reduce mortality in women from the Walaita zone diagnosed with diabetes? Again, here, we're looking at a specific intervention. In this case, it would be milk consumption. And we're testing out to see, are there any measurable attributes and outcomes and differences between those who have exposure to this intervention, women who consume milk at 5 or more times a week, versus women who do not have exposure. And we're going to assume that all things being similar between the 2 populations, and the only variable differing between them is consumption of milk. 3 basic questions. What's happening? Is there an association? Or what is the impact? So designing the study is complex, and a fundamental decision is whether to take a passive role in assigning an exposure on study subjects, in which case follow the no part of this slide. And if you were not to assign an exposure, then you would have an observational study. If you would assign an exposure, so if you go to the yes bar and apply an intervention and examine the effects, then what you have is an experimental study. And today we're going to look more closely at study designs from these 2 categories, observational and experimental. So, observational. The goal of an observational study is to observe and collect data on characteristics of influence without influencing the participant, their environment, or disease course. Among observational studies, two common designs are cohort studies, in which observations are made in a group of subjects that is followed over time, versus cross-sectional studies, in which observations are made at a single point of time. Well, okay, in contrast to observational studies, let's move to the experimental studies. The goal of an experimental study is to deliberately influence the outcomes and investigate the effects of an intervention on a specific population of subjects. For experimental studies, where you assign an exposure, you need to determine whether you're going to randomize exposure to an intervention, which means assigning group 1 to be exposed or participate in an intervention, and group 2 not to be exposed or not to participate. So these are typically some form of a randomized control study, if you choose to randomize them. If you do not randomize and instead select some other means of selecting ways to compare groups of people exposed to an intervention with another group that is not exposed, then you have some kind of quasi-experimental study. So again, two overview types of studies, observational and not observational. And the main points between them are you going to observe and see what characteristics exist within your population, versus do you want to introduce some intervention or exposure and see what the effects or the impacts are. Another key design decision you need to consider is time. When will your data be collected? Retrospective studies examine data collected over a period of time that starts at the current time and looks backward, versus prospective studies, where we begin at this current point in time and follow subjects longitudinally into the future at a set points when data will be collected. So remember the three types of study design questions I mentioned earlier. First, what is happening? Second, is there an association between A and B, or X and Y? And then 3, what is the impact of an intervention? So another way to think of your study design is by what kinds of questions it will answer. Cross-sectional and cohort studies can tell us what is happening in a community or population, and also if there's an association between two variables. Case control studies can tell us if there's an association between two variables and the impact of an intervention. And randomized control trials or clinical trials are best used when you want to evaluate the impact. So are there any questions? If not, we're going to proceed and talk in detail about each of these 4 major study design types. So let's start with cross-sectional studies. Cross-sectional studies are a type of observational study, as I mentioned before, meaning researchers collect information about study subjects without changing the environment. So we might simply measure the cholesterol levels of women who consume milk and those who not consume milk, along with any other characteristics that may be of interest. Going back to the example I gave before about, is this question of, do women who consume milk, a good research question? Now we want to look a little more specifically. What we're looking at is simply selecting a population and analyzing milk consumption along with some other factor that we'd like to analyze. One defining characteristic of a cross-sectional study is that it can compare different groups at a single point of time. So again, we might measure the cholesterol levels among women who drink milk across 2 age groups, age 40 years and over or under 40 years, and compare these to cholesterol levels among women who do not drink milk in the same age groups within a specific population that might be bounded by a geography or something. But we can also create additional subgroups within this population to look at, such as different education levels. However, we would not want to consider past or future cholesterol levels. we're only looking at cholesterol levels and milk consumption at a single point in time. So things to keep in mind with this example of a cross-sectional study. Again, all measurements are made at once and there's no follow-up. It's best used simply to calculate prevalence or describe the characteristics within a population. One of its main attributes is that cross-sectional studies can usually be done relatively quickly and more cheaply, but it also allows researchers to compare many different variables at the same time. So we could, for example, again, look at age, gender, income or educational levels in relation to milk consumption and cholesterol with little or no additional costs. So let's look at a specific example of a cross-sectional study, give a little more specificity to it. So the study I'm going to describe to you is by Dr. Gan and his colleagues on dietary aflatoxin exposure and its effects on the growth of young children in Benin and Togo. So the title of the study is on the slide, and I'm just going to talk through a description of it. So people in certain areas, communities in West Africa, are not only experiencing high levels of undernutrition, but also chronically exposed to high levels of toxic fungal metabolites or mycotoxins. One family of mycotoxins, the aflatoxins, are carcinogenic and cause growth retardation. Aflatoxins contaminate staple foods, many of the staple foods in Benin and Togo, particularly maize and groundnuts, as a result of the hot, humid climatic conditions and also the storage conditions that they're kept in, and then this promotes fungal growth. So Dr. Gan and his colleagues wanted to study exposure to aflatoxins and the relation to anthropometric measures in children in Benin and Togo. So the study team collected data from 480 children, ages 9 months to 5 years, from 16 villages in 4 zones. Measures they collected included child height, weight, and age to calculate their Z-scores, then socioeconomic, demographics, and aflatoxin exposure over the prior 3 months by measuring aflatoxin bound to albumin in the blood. The results that they found was that 33% of children within this study were stunted, and 29% were underweight, and 6% were severely stunted or wasted. Children who were malnourished had 30 to 40% higher mean aflatoxin albumin concentrations. So this is what they found, and again, they were able to collect data from this rapid assessment of surveys that were collected at one point in time. And with it, they were able to look at and assess multiple potential associations between their outcome variable of interest, and that was the child stunting. So, to summarize, with cross-sectional studies, let's look at some of the strengths and weaknesses and what we saw specifically from the Gan study. So some of the strengths, right, is that it was fast. And 2, relatively inexpensive. They could go out and collect the study data. And they weren't implementing an intervention or having to monitor or collect data at multiple points in time. What's great about it is that it can provide an accurate estimate of the population prevalence if their sample was carefully selected and if they had a representative sample of children between this age range that they were looking at, 6 months and 59 months. And what could also happen from it is, based on what they found, right, is that they found that children who were malnourished were more likely to have higher aflatoxin concentrations. So from that finding, they may generate a new hypothesis, or they may be able to go in and study in depth some additional questions to look at. And the final thing is that it allows you, again, to study multiple outcomes and exposures. For example, they could look and compare whether there was aflatoxin concentrations with stunting as well as underweight, so 2 different measures of child nutrition, or if there was only associations between aflatoxin exposure and child stunting, but no association with underweight or wasting. The weaknesses of cross-sectional studies is that you cannot establish causal links. So with this, for example, we don't know if it was the aflatoxin exposure that resulted in a higher risk for the children to be undernourished, or if the other is true, if that child undernutrition led them to be more susceptible to aflatoxin risk and the effects of it. The second weakness of cross-sectional studies, everything is measured as a single point in time, so we're not able to capture if it was just a blip, and if we had taken that same data 6 months later when child's weight measures may have been different, if the results may have looked differently. Another weakness is that it can be impractical for studying rare diseases or those that have a short duration. And finally is that it can be susceptible to selection and measurement bias. Any questions about cross-sectional studies? If so, please pause the recording now and take down those questions before continuing. When we resume, let's take a look at cohort studies. So cohort studies are a study design with one or more groups called cohorts who are followed prospectively, and subsequently we evaluate the status of the populations with respect to a specific disease or outcome. And what we want to do with a cohort study is determine which initial participants' exposure to the certain risk factors and whether those risk factors follow them, who then present with the conditions further into the study. So as the study is conducted, outcomes from participants in each cohort are measured, and relationships with specific characteristics are determined over time. So one of the key elements of cohort studies is that we look at the relationship between a specific exposure and an outcome. For example, we might design a cohort study to assess the impact of feeding school children breakfast on their attendance or on some other performance outcomes. We select 2 schools, if we were to do this, that should be nearly identical in terms of the number of students, their ages, economic backgrounds, geographic location, and academic performance and attendance. We want them to be nearly similar at baseline. But then over the school year, children at one school may be fed breakfast, while students at the other school are not fed breakfast. So we can see whether there are changes over time. But everything else remains the same. At the end of the school year, we then analyze performance from students from both groups by comparing final exam results and attendance. Our analysis may show a significant difference between cohorts in terms of the performance based on this one factor of school breakfast feeding. And you'd want it to be based on that one factor and not due to something else. All right. So with cohort studies, a few things to keep in mind. What's unique about cohort studies is that it examines the relationships between an exposure and an outcome. This is different from a clinical study in that you're not randomizing participants, but you're simply looking at population-level groups. With cohort studies, they can be retrospective or they can be prospective. It generally involves following groups of subjects over time, though, to generate evidence between this exposure to a disease or an intervention and when outcomes arise. And that what we want to assume is that the time between exposure and the variable is going to be relatively short. Like cross-sectional studies, they can be used for descriptive or association studies as well. So now let's take a look at an example of a cohort study. This one is by Tedessa and his colleagues in rural Ethiopia. So in many communities, I think this is from the RC region, in many rural communities in Ethiopia, as you know, diets of pregnant women are predominantly plant-based and provide imbalanced macronutrients and inadequate micronutrients. So dietary diversity is one measure of food access that can be used as a proxy for nutrient adequacy of the diet at the population level. So this cohort study investigated the association between dietary diversity during pregnancy and perinatal outcomes, including maternal anemia, low birth weight or LBW, and preterm birth weight PTB, as well as stillbirths. So the researchers conducted a prospective cohort study among 374 pregnant women who attended antenatal care visits among 8 health centers and 4 rural districts in the RC zone. The exposure of interest was dietary diversity, and women were classified as either having adequate diets, which mean consuming 4 or more food groups, and so these would be the cases, or the participant cohorts, excuse me, and those who were inadequate diets, and those were women who consumed less than 4 food groups. What the analysis showed is that the 2 groups of women were not significantly different in terms of their monthly incomes, land size, or previous abortions between those who consumed 4 or more food groups and those under 4. However, the 2 groups did differ significantly in the number of years of completed schooling, their height, and also their weight. So among the adequate dietary diversity group, women consumed more dairy, animal source foods, and also vitamin A-rich vegetables. So this meant as they added more foods to their diet, the foods that they tended to add became more nutritious and tended to include animal source foods. What the study also found was that women in the adequate dietary diversity group had a lower risk for anemia, low birth weight, and preterm birth, but not of stillbirth, than the women in the adequate group. So strengths and weaknesses of this type of study. First, the strengths is that it's really powerful for defining and establishing population-based incidence. Second is that it's better at establishing the causal links because the potential predictors are measured before the outcomes. Third is that the temporal relationship is clear, that you're establishing what the relationship is at the beginning of the study or one point in time, and then following your cohort to see when the variables that you're looking at do emerge. And finally, compared to prospective case control studies, it's much less costly and time-consuming. Again, because you're not setting up specific longitudinal points when you're collecting data, you're just looking at it still at points in time. The weaknesses, though, is that it can be time-consuming to go out and collect population-level data because you need to have large enough sample size in order to be significant and to generate enough power with your sample. And this can create more expense. At the same time, it can be less consuming than doing these studies over multiple years. Another weakness, though, is that you have less control over the nature and the quality of the measurement because you're not confining the group to those who are specifically signed up and participating in an intervention over time. Is that you might get participants and you might get bias within your results that are due to some other factors beyond what you're assuming with your statistical analysis. Another weakness is that some important measures or data that really are affecting the outputs and the outcomes that you're seeing may be missing from the data set. You may not have collected that important data. And then the final 2 is that you could lose participants over time, and that's going to affect the power again and your ability to infer that there's an association due to the findings and not due to some other effect. Any questions with cohort studies? If not, or if yes, there are, please pause the recording now and take them down before we continue. Okay, our next example is the case control. So this type of study compares patients who have a disease or outcome of interest, termed cases, with patients who do not have a disease or outcome, termed the controls, and looks back retrospectively to compare how frequently the exposure to a risk factor is present in each group to determine the relationship between the risk factor and the disease. Case control studies are usually observational because no intervention typically is attempted, and no attempt is made to alter the course of the disease. The goal of a case control study is to determine the exposure to the risk factor of interest from each of the 2 groups of individuals, cases and controls. These studies are designed to estimate odds and risk for a disease. Case control studies are known for being effective to study rare conditions, as less time is needed to conduct the study compared to a clinical trial or a randomized study. And this is because the condition or disease typically has already occurred. And it also allows the researcher to look at multiple risk factors simultaneously and can be used as an additional study to establish an association. So with case control studies, let's look at an example of a specific study. And this one is from Nigeria. So this is by Dr. Thatcher and his team. And it's a case control study of factors associated with nutritional rickets. So in the case of this study, let me start by asking, does everyone know what rickets is? So if not, it's a skeletal disorder that's caused typically by a lack of vitamin D, calcium, or phosphate. So people with rickets may have weak or soft bones, stunted growth, and in severe cases, skeletal deformities, which are most commonly seen in young children between the ages of 6 and 54 months. So the question the study team wanted to answer in this study was what factors were associated with rickets among Nigerian children. So the total study sample was 246 Nigerian children, 123 cases, meaning they did not have the disease, in this case rickets, and 123 controls, meaning they did not have the disease. Right? I hope I said that right. So 123 cases who did have rickets, and 123 participants or controls who did not have rickets. So the team then collected basic dietary, demographic, anthropometric, and biochemical data from the children to assess factors related to calcium and vitamin D status. And what they found was that calcium intake was low among all children, both cases and controls. Children with rickets or cases were more likely to have a relative with a history of rickets, as well as have a shorter mean duration of breastfeeding when they were under 59 months, and also a delayed age of walking than the controls or those without rickets. They also found that the median hydroxyl vitamin D concentrations were 32 nanomoles per liter for children with rickets, but 50 nanomoles per liter among the control. So this was an interesting finding in this case, right? What they thought they were going into the study, what they thought they were going to find from the study was that because the symptoms of rickets were bone deformities, they would find a lack of calcium and calcium associated with cases who had rickets. But what the results showed that was that within this study population, low dietary calcium intake did not account for rickets. Instead, it was vitamin D that showed an association. So they suspected that inadequate dietary calcium probably interacts with other genetic, hormonal, and perhaps nutritional, in this case vitamin D, factors to cause rickets in susceptible children. So again, specific to the study population is what the finding is in cases in case control studies. So from this example, what can we learn about some of the strengths and weaknesses? What can we see as them? The first is that the case control is really helpful when randomization is not feasible. You're not going to assign 246 children to participate and give 123 rickets, right? It's better in this case to already look at people, in this case children, who have a disease and look in their past to find out what are associations that may have led to it. It's also effective for studying rare outcomes and rare diseases as well that might have a very small population that it would be difficult to find. It also has a relatively short duration of the study. You're not waiting for a disease to emerge, but it's already occurred. And it can be relatively small, or small in terms of expenses and short in terms of duration. And the final thing is from the study is that you're going to get an odds ratio to know what the odds and the risk of having this disease is, looking at and specific to different variables. The weaknesses with case control studies is that the information available may be limited to the specific population that you're working with. What you found as associations in this study in Nigeria may not be the same results that you would find if you were to take the same sample from the Sidama zone in the SNMPR. The other issue is that you're only really able to look at one outcome at a time and not make the same inferences for other outcomes. It can also be subject to different bias depending on what your measures are. And it doesn't tell you about prevalence within the total population, right? Because you're only able to look at prevalence within a group that's already been identified as having a population, rather than trying to understand what's the prevalence of rickets within this entire geographic setting in Nigeria. So, our next study, actually before moving on, if you have any questions about cases and controls, please pause the slides now. And then when you're ready, we'll resume and move on to experimental design. The final study design we'll discuss is experimental design. In this type of study, the researcher deliberately influences the environment or some factor among participants in order to investigate the effects of an exposure on a carefully selected population of subjects. So when experimental studies are done in human subjects, we typically refer to them as clinical trials, or RCTs, randomized controlled trials. When you design an experimental study, you first want to consider the issue of defining your target population. After identifying these criteria, you need to consider how you will actually assign participants to receive the treatment or not. You want to ensure that your two groups of subjects are similar in nearly all ways except for the exposure you are delivering. Why is this? This is so any changes you record in the exposure you are introducing can be due to that variable and not another factor. So when possible, you want to assign your subjects into groups based on random assignment rather than selecting them. This helps remove human bias or groups having some other factor in common that may otherwise confound or bias the results. So any questions? Probably a lot right now, right? So again, with the experimental design, what you want to start with is read the slide from left to right. You select participants and your sample from the total population, and you need to carefully define and select your criteria for what those reasons are. You have to establish, your selection criteria for how you will choose your sample. Your next step is to measure baseline variables, and this is done so that you ensure that your two groups really are similar in all aspects, except for that one variable that you want to introduce. Next, you want to then randomize the participants so that you're not introducing selection bias in whether they're receiving the intervention or exposure or not. Your next step, number 4, is to apply the intervention and then determine the period of time when you're going to monitor and collect data to track effects. You're going to follow up with them, and then at the end, at one or multiple points in the future, you'll measure your outcome variables. So now let's look at a specific example of an experimental design applied to nutrition. So this study evaluated the impacts of a 2-year integrated agriculture, nutrition, and health behavior change program targeted to women in Burkina Faso. So the question the study team asked was, what is the effect of Helen Keller International's, HKI, their 2-year integrated agriculture, nutrition, and health behavior change program on women is what the program was targeting, but they wanted to look at the impacts of this program actually on child anthropometric scores, their mean hemoglobin, their anemia, and also diarrheal preference. So the study methods were to cluster randomize the village. Cluster randomization is a type of randomized control trial where groups of subjects, as opposed to individuals, are randomized. So just because the study team randomizes at the group level, they may still be interested in outcomes of analysis at the household or individual level. But the clusters tend to occur at the geographic level. So they're looking at picking communities or villages. So why did they do this? Why did they cluster randomize? So CRTs are more commonly used to evaluate public health and community nutrition and health policy interventions as opposed to clinical interventions. Cluster randomized trials are also useful when individuals randomized to different groups are in frequent contact with one another and thus may be influenced by talking with their neighbor. So this is often the case when the intervention, again, is more behavior change or educational in nature. So that was the study question and the intent of their design. The study team in Burkina Faso selected 55 villages and randomly assigned 25 to be part of the control group and 30 to be part of the intervention. The intervention had different levels, so the control groups were further differentiated by who delivered the behavior change messages. And they had two of these groups. One was older women leaders, and then the other was health committee leaders who went through a training. Between the baseline and end-line periods, here are the results. They found marginally significant impacts on child hemoglobin and wasting rates, but statistically significant impacts on diarrhea prevalence among children ages 3 to 13 months in the treatment groups compared to the groups that did not participate in the intervention. They also found impacts on anemia among children in the younger age group who were born during the intervention. However, they did not find any impacts on stunting or underweight prevalence overall, which may be due, again, to the relatively short duration of the intervention and also the time at which these child height, weight, and age scores were being taken, height and weight in particular, scores were being taken where children have natural growth curves anyway. Okay, I shouldn't editorialize. So wrapping up, so what did the authors learn from this? The authors learned that it wasn't only the intervention that mattered, but also who delivered the messaging that resulted in significantly improved child outcomes. Okay, so this is really huge for those of us who work in community nutrition and particularly work on nutrition-sensitive agricultural programs, because there are very, very few studies that do have any impact on nutrition outcomes. This study was significant because it's one of the first to establish and to see a household food production intervention that had statistically significant positive effects on child diarrhea, hemoglobin, and anemia outcomes. As I mentioned before, it did not impact the child nutritional status, and there's a whole body of literature, and that's hopefully what you will be looking at in your future research studies, but it did establish some other effective change measures. Okay. Strengths and weaknesses. This is why I should not have picked this study, because I want to talk about the study and not the study design. All right, so strengths of experimental design. First is that it can produce the strongest evidence for the cause and effect, right? Because it's less due to random or confounding bias within the environment, because you've carefully set selection criteria for who your study population are, and you have carefully already tested and validated your survey designs and the intervention that you plan to implement. So any effects that you do see, you can show the pathway and have evidence for why it is a result of this exposure and not something unknown. And again, because of this, it may be the only design depending on what your study questions are. It also has the opportunity to assess whether the intervention itself caused the observed outcomes or if there was something else introduced in the environment that may have influenced it. Because at times the lack of effect and lack of results may be another result in and of itself, which we can talk more about. And then the final one is that it can produce a faster and cheaper answer to research than the observational studies at times, especially long-term longitudinal cohort studies that are looking over not just 2 years of study, but 20 years of study. So at times that clinical trial may actually be cheaper. Weaknesses of experimental designs, though, is that they tend to be viewed as more costly in terms of time and money, because you do need to go through all these additional steps of the process of assigning groups to participate or not, and your research protocols. It also can raise questions at times in terms of its suitability for the ethicalness of what your intervention is, and in terms of cases when you're assessing an outcome that may be rare to see. The final, or the additional weaknesses to experimental designs is that they tend to restrict the scope and really narrow your study question. You have to be very specific about what you're looking at and want to see. And then finally is that depending on the nature of your clinical study, you may have a high dropout rate when the intervention has undesirable effects, or if it's carried out over too long of a period and people cannot feasibly continue to participate. Whew, okay. So with that was a quick and dirty overview to study design, and there was far too much information in far too short a time to really pay adequate attention to each. So I apologize for that, but I hope it gives you a high-level review and summary of just some of the general characteristics of the 4 types of study designs. What I'd like to do next is test your knowledge, review what it is that you picked up and learned just going through those slides. And to do this, I'm going to have 3 questions, and you as a group think about this. So the first question is, which of the following is an advantage of a case control study? A, is it that they can simultaneously look at multiple risk factors? B, that they are useful to initially establish an association between a risk factor and a disease or outcomes. C, that they take less time to complete because the condition or disease has already occurred. D, E and C only. Or E, A, B, and C. If possible to pause right now, please pause the recording so that you can think about this or discuss as a group. And in 10 seconds, I'm going to go ahead and circle the answer for you. So the correct answer for this is A, B, and C, all of the above. And if there are any questions about this, again, please let Fukado and myself know. The next question. Cohort studies generally look at which of the following? A, determining the sensitivity and specificity of diagnostic methods. B, identifying patient characteristics or risk factors associated with the disease or outcome. C, variations among the clinical manifestations of patients with the disease. Or D, the impact of blinding or masking a study population. And again, take 10 seconds if you would like to pause and discuss. And the correct answer to this question would be B, identifying patient characteristics and risk factors associated with the disease or outcome. How many of you got that right? All right, last question. Having respondent bias in the treatment group of a clinical trial is a good thing because it means the study participants are eager and make the study stronger. A, true, or B, false? And I'm going to come back and give you the answer. This is B, false. We did not go in depth about bias and the types of bias, but we are going to talk about that for a future session. So this one was a little of a trickier question, as I only referred to bias very briefly and I didn't define it today. But hopefully those quizzes left you feeling a little more confident about some of the information that hopefully you got from this online webinar. And if you did have questions, feel free to review the slides again or reach out to me and Fukado and ask questions. So just in summary, I want to go through some of the key points from each of these 4 study designs yet again and hit the highlights. So again, experimental studies. randomized control trial is one of the gold standard for experimental studies. And randomized control studies are really helpful when you need to randomly assign participants into different groups within a study. It's very helpful when you want to establish cause and effect from a specific exposure or intervention. And it can also be really important for testing the efficacy or effectiveness of an intervention or of an exposure. Case control studies are appropriate when randomization is not feasible or ethical, or when it's not possible to randomly assign participants into groups. And they're also helpful when conclusions must take into account potential bias. And then they're helpful for showing associations and trends, but they really cannot test cause and effect. Next, cohort studies are studies that can help establish whether exposure is associated with a subsequent outcome. Cohort studies tend to include two populations who seem the same except for the hypothesized exposure. They examine the population and different relationships to an outcome or disease. They establish the temporal sequences sometimes between exposures and outcomes, and they allow the examination of multiple exposures and outcomes. And finally, cross-sectional studies. Cross-sectional studies are really first useful for hypothesis generation, helping you get to know a population and what some of the prevalence and current trends are within them. And then they can also help you to establish whether exposures and outcomes that are observed simultaneously in order to assess what's the current prevalence within the population. And the key thing, again, with the cross-sectional studies is that they're taken at a single point in time, so they can be rapid to conduct and just give you a good snapshot of what's going on. So with that summary of this study design, for the rest of the session today, I want you to take time in small groups, working in groups of 3 to 4, to work on assignment number 2. So assignment number 2, there are 4 manuscripts in the box site for this week. And each one of your groups for today, you can select, to be honest, whichever study you want to look at, but your assignment that you must turn in is you must review 2 of those articles and answer the following question for each of those 2 studies that you turn in. The questions that you must answer are, number 1, what study design was used? Was this a cross-sectional, a cohort, a case control, or a randomized control study? Number 2, you have to answer the subject eligibility requirements. What were the comparisons that were used in the selection criteria that the researchers established to assign the groups as they were? Next, number 3, give the dates of recruitment and the follow-up for the study. So give the study time frame. Number 4, identify how many subjects were exposed to the intervention, how many were unexposed, and how many subjects total there were participating. Number 5, identify what the sources of data were used to define the outcomes. So were these data sources from household surveys? Were they from some other secondary source of information, some existing data set? Number 6, briefly state the main result from the study. Number 7, describe what you think the major strengths of the study design are. And for this, you can go back in the slides to those tables that I had that identified strengths and weaknesses for each type of study design. And in addition to listing the major strengths, at least 3 for each, also identify the major limitations. And so this assignment is really supposed to give you time to critically read and evaluate some journal articles and look at them through the lens of, what kind of study design did the researchers use? And break down those study design parts into some of the key ingredients. All right, so take the next 15 minutes or half hour, however much time you have, and feel free to talk together and work in small groups through this assignment. And if you have any questions, let us know. With that, I also want to let you know that we will send you information about assignment number 3 over the weekend, and to please let us know as you have questions. With that, thank you so much for your time today, and I'll leave you with this quote by a scientist from Russia who won a Nobel Peace Prize, I think, for some research he did on vitamin D. Scientific inquiry is seeing what everybody else has seen, but thinking what no one else has thought. Thank you, guys. Goodbye.